Hello, everyone. Welcome to another exciting session of NextGen 23, the industry's largest drone autonomy summit. Audience, before we begin, it would be great if you could let us know where are you joining from, what do you do, and what excited you about this session. Volatus team has developed the AERIEPORT, a new nesting station for drones. The team of engineers led by Pedram completed market research to identify key gaps in existing nesting stations before designing the AERIEPORT to meet global regulatory safety standards. The AERIEPORT is designed to detect and avoid, operate in extreme weather conditions, and comes equipped with redundant safety systems. It is also drone agnostic, scalable, and able to operate in off grid remote environments with solar or wind energy. BVLOS, beyond visual line of sight applications for drone usage, was one of the key focus, enabling multiple tasks such as pipeline and railway inspections, mining security, and mapping. With the data collected remotely by the drone, inspectors can build maintenance schedules based on the condition of the components and understand how parts and structures degrade over time. To share in detail about the capabilities of the AERIEPORT and how it is enabling BVLOS operations, I would like to welcome Pedram Nowrouzi. Pedram is the co-founder of OmniView Tech, now a Volatus Aerospace company. Pedram holds the position of CTO for Volatus Aerospace group of companies and is developing a number of technologies from drone nesting stations, terrestrial crawlers, and inspection drones. He is a trusted, seasoned business and technical leader that works with executive management teams to help grow tech businesses that exceed expectations. He has an incredible passion for aerial technology and has garnered over 6,700 hours of flying unmanned aerial systems. Pedram possesses over 2 decades of experience with robotics and electronic systems and has built, tested, and flown numerous custom-built unmanned aerial systems. Before I pass it on to Pedram, I would like to share a few housekeeping rules. Please type in your questions in the Q&A tab of the session, and it will be answered at the end of the presentation. The session is getting recorded and will be published soon. We also have a Volatus booth in Expo section. Please make sure you visit it during the networking and booth visit slot. Finally, please remember to capture your favorite moments of the session and share it on Twitter and LinkedIn by using hashtag NextGen23 and tagging Flightbase. Few lucky people who share might have a surprise in store. I would also like to thank our title sponsors, title sponsor DJ and platinum sponsor Volatus for supporting us. With this, over to you, Pedram.
Thank you very much. I'm just going to go ahead and share my screen here. Thank you very much, and I'm super excited to be here and presenting the AERIEPORT. I'm going to jump right into it, and we're going to start today talking about some key points, and we're going to dive into what makes the AERIEPORT different from all other nesting stations currently on the market. So some of the key points of the AERIEPORT, it was specifically designed with BVLOS in mind. So right at the beginning with the engineering team, what we decided to do is read up on the regulations and really understand the regulations in the multiple different areas that we're expecting our nesting station to be operated in. As an example, looking at the regulations in the US, looking at the regulations in Europe, and looking at the regulations locally here in Canada, where we're located, and really understanding what is the safety requirements of these nesting stations and what are the operational requirements of these nesting stations. So some of the key points of our nesting station, it does have an optical detect and avoid system. Currently, we're using optical detect and avoid system. However, you can put any sort of detect and avoid system. So our system is extremely well-rounded and it's very open source so that we can have any sort of detect and avoid system be integrated into our workflow. So whether it's radar, it can be panel detect and avoid or an optical detect and avoid, all that is meshed into one or it can be used separately. We can also control the nesting station from anywhere in the world. We've created a 4SIM module that sits both on the nesting station and also on the aircraft itself, so that we're communicating to both separately. Which I'll go back into a little bit more detail in later slides as why it's so important to be able to communicate to both independently. But basically, you're able to control the nesting station in the drone from anywhere in the world utilizing internet, whether it's LTE, 5G, SATCOM, or any sort of mesh networking. We also have assigned and designed a flight scheduling assistant. What the flight scheduling assistant can do for you is basically you can set up flights to be carried out autonomously multiple times or a specific periods of time throughout the day, throughout the month, or throughout the week. So that scheduling assistant, as an example, you can say every day at 2 o'clock, I would like the dome to open up, the drone to go out and carry out a specific mission, come back and land. And I want you to do that every day at 2 o'clock. The nesting station will carry that out. And something that's very interesting is actually in our workflow, we've included the weather station into that workflow. So if we do want the nesting station to execute something every day at 2 o'clock, like I use as an example, if the weather station does not permit just because the weather is not suited for that aircraft's flight, then the nesting station will not open up and send you a notification letting you know that we have not opened up because we could not carry out the flight. Another really key feature with nesting stations, something we saw as a void in the market, is that we did not see nesting stations that can withstand extreme temperatures. So we really designed our nesting station to be able to accommodate all sorts of temperatures, be executed anywhere in the world, and be deployed in anywhere in the world. So our operation temperature is -55 to +55, and you can also do remote control flights 24/7, 7 days a week. What we've done is I've created this chart. It is a little bit glorified, and the purpose of this chart or this image is to depict exactly the different components of our nesting station. Once you see the image of our nesting station, it is a little bit more compact than what you see here, but we've divided all the different components into different sectors so we can better showcase it to you guys. So if you go look at number one on your very left-hand side, that's our solar system. That could also be replaced with a wind energy system as well, or any sort of power source that can be connected into the nesting station. We have been developed to be fully off-grid, and that's the reason why we do have a solar or a wind or an off-grid option with our nesting station. Option number two is our weather sensor or our weather station. This gives you full detail in regards to humidity, temperature. You get droplet size if it's raining, and that's really important. I'll go into a little bit more detail later. And we also get wind speeds as well. The next to that is number three, and that's our C2 link, our command and control module. Next to that, we have our drone in the box, and number five is the box itself. And number six is our detect and avoid system. So these are the main components that make up the AERIEPORT. So I want to do a little bit of a deep dive on this, every component that I just spoke about in terms of what is fit under that subcategory. So the control box houses our LTE internet connection. That could also be SATCOM or mesh networking. We have our modem to supply the internet to the different various components. All the control systems are also located inside that box. We have a miniature HVAC system inside of our control box for the purpose of being able to operate in extreme temperatures and making sure that all of our components on the inside are not affected by external weather. We also can house a remote controller in there. That's specifically for DJI, as DJI has a checksum in their algorithm to check for an RC being physically around and available. So that RC can also be housed in there as well. We also have a two-way aviation radio that's been integrated into our nesting station. The purpose of that is for many of the regulations and the regulators around the world, they want to make sure that because we're operating in a BVLOS environment and we're not able to see our nesting station, we can announce ourselves to other incoming traffic and manned aviation. So we do have a two-way aviation radio. No matter where the nesting station is located, we're able to communicate from our computer or from our operation center, and it will be dispatched to the nesting station, and nesting station will broadcast it. And same goes the other way around. If an aviation system is around, or airplane is around that's equipped with a radio, aviation radio, we would be able to hear them as well. And we also do have an ADSB system inside that box as well. Next, we have our weather station, like I was talking about earlier. We can detect humidity, temperatures, wind speed, rain, and also we've used the infrared sensor to detect the rain droplet size. That's important because some of the IP ratings of aircrafts out there define how much rain or how much water can be spewed over the aircraft. So that's the reason why we're using an infrared sensor to detect the droplet size. We also have a DAA system. Currently, we're integrated with the Cassia G by Iris Automation. We also have integrations that we're currently working with radar companies, so that we can get a larger field of view of oncoming threats. And all that threat is displayed on a screen, which I'm going to show you guys a little bit later, our flight operation software, and exactly how it's displayed on the screen and what the pilot can see and view on their screen. We also have a lighting system that has a built-in speaker, and that's more for alerting. So every time the aircraft is taking off or landing, there can be a pre-recorded audio file. As an example, they can mention that aircraft is about to take off, please stand clear, or aircraft is coming in for a landing, please stand clear. And all that can be pre-recorded. You also do have the ability of doing a direct intercom to that radio as well, so we can communicate with anyone that's in the vicinity if need be. We also have the flashing lights, the red flashing light. Again, it's more of an alerting light to let you know that the aircraft is coming in for a landing or taking off. We also have dual spotlights on the outside. That's more for examining the airport, and which is located right next to a daytime, nighttime EOIR camera. So our camera can see at night, but we've also included spotlights so that we can do a little bit better with inspecting our nesting station, as it's going to be remote. At the bottom section of our nesting station is where our HVAC system is housed. So our HVAC system can handle both cold and hot temperatures. And above that, we have our power management units. We're going to go do a deep dive look into the nesting station dome once the dome is opened up. Inside there, we have a 360 live feed camera. And this was specifically done to meet with the regulation. We were requested that we would need to do pre-flight checks, and we would need to check every single propeller and make sure that the aircraft is in an airworthy state prior to taking off. So we've included 4 cameras. They are also EOIR cameras, so that you can inspect the aircraft prior to taking off. We also have PTC heaters to aid in heating of the nesting station in extreme cold weather. It does use a lot of efficiency when you're trying to just use a HVAC on its own. So what we've done is we've included 4 PTC heaters that will aid the HVAC in heating the dome to make sure that there's no ice buildup or any sort of snow sitting on our dome, but also to make sure that the HVAC system isn't overworking. And the reason why we've included 4 PTC heaters is also for redundancy. God forbid if 1 or 2 of these systems go down, we're able to still use our PTC heater and also our air exchange system to keep the system cool or hot depending on the external elements. Above, we also have our charging pad. Our charging pad is connected directly to a BS60 DJI charging station, as we are in this demo using a Matrice 300. And this will also allow us to turn on and turn off the aircraft. We are not tied into the Matrice 300. We are drone agnostic, so we can have any sort of drone be housed into our nesting station. And our charging system can also be hooked up to any sort of charging power management unit. So we're not tied to any specific charging PMU system. We're also not tied into any sort of aircraft that we have to use. We're fairly open source in multiple different ways. And our charging bars can do other things other than turning on and off the aircraft and charging the battery. They can also recenter the aircraft when it comes in for landing. So this is our app. This is the Q100 debugging app. We do have a full capability of controlling our nesting station using our flight operation software. But again, because we are trying to be very redundant, what we've done is we've created a Q100 app, which is used for debugging and remote controls. If for any reason we cannot push out a specific command utilizing our flight operation software, we do have a backup Q100 software that can route directly to the nesting station, and we can push out commands either from the drone to the nesting station or vice versa from the nesting station to the drone. And our Q100 app gives us the ability to control the canopy, start charging, turn on our internal computers or turn off our internal computers. We can also do other things like calibrating the aircraft, calibrating one key takeoff or calibrating any sort of RTK GPS systems as well. This is a little bit of an insight to how a threat is seen when it is ingested by our detect and avoid system. So in this example, we're using the Cassia G, and on our flight operation software, you can see that the green triangle, which is our drone there, is flying, and our detect and avoid system has detected an aircraft. And if you look at the top, what you can see there is it will show you the threat, the location of the threat, the heading, the speed, and the distance away from the aircraft that's flying. This is all very important for BVLOS, as we need to be aware of our uh, airspace around us to make sure that we're performing our flight safely, but also it gives us an idea of what's going on around us. Next, I want to show you how our nesting stations are displayed on our flight operation software. So with one flight operation software, you can control multiple nesting stations, multiple AERIEPORTs. And what we've done is we've color coded them. So if a nesting station goes offline for any reason, on our flight operation software, it'll show it as gray. If a nesting station does not have an aircraft in it, it's online and can accept any aircraft, then it would be green. And if the nesting station is housing an aircraft inside, then it would show it as red. The purpose of this is because our nesting station is not on a one-in-one commitment between the aircraft and the nesting station. You can have multiple nesting stations deployed and have multiple drones drop in and drop out of those nesting stations, which gives us the ability for future proofing to have the ability of hopping from one nest into another nesting station. Going to jump back into the nesting station and some of the key features. We do have live data camera feed directly streamed to our control center. This gives us the ability for pre-flight checks, but also making sure of the well-being of our aircraft, and it gives us some capability of doing diagnostics remotely. We have live weather system. Our weather system is constantly live and pushing data out to our servers. And the really interesting part of this is that we can deploy multiple of these nesting stations in a certain area and have the live weather system connected to an AI platform to let you know the weather in different areas and whether if the weather is approaching to a certain nest or to another nest. This is also for future proofing ourselves, having the ability that if a drone is executing a flight, but it does need to go into another nest, it can determine the perfect nest to jump into depending on the weather as well. Our nesting station is very drone agnostic, like I mentioned earlier. You have the ability of putting any sort of aircraft in it. Blade from blade tip to blade tip, diagonally, will be 82 inches. Doesn't mean that we're restricted to this size. It just means that our current airport can only handle that kind of size. If in any case we do have a client request that they need a bigger nesting station, we can simply take our electronics out and build a bigger enclosure to house the nesting station. So we are not limited by the size of the AERIEPORT. We're just limited. We're not limited. We can increase those limits by just making a bigger enclosure of a nesting station. We have a built-in HVAC system, like I said earlier, and also automated power management system. Some of the capabilities and specs of the nesting station. So compatible drones, we can be compatible with any drone as long as we're given the SDK API or the company or whoever the manufacturer is willing to share that with us, or we can give them access to our nesting station so that we can be compatible with it. Currently, we're compatible with all DJI products. We're compatible with all Autel products. And also, we are developing some Ardu Pilot and PX4 systems that are also compatible and capable of landing in and out of our nesting station. The endurance of the nesting station is really dependent on the aircraft. We are doing charging. We're not doing battery swaps, and we find that just to be a little bit easier at the current moment, just making things a little bit less complicated because we can have complications with nesting stations that do swap out batteries. Our communication and connection type can vary from anywhere with SATCOM, 5G, LTE, mesh networking, or local networking, private networking as well. We're not limited in any way. Temperature range, like I mentioned before, negative 55 degrees Celsius to plus 50 degrees Celsius. And payloads, also it's drone dependent. As long as it does not exceed the flight limitations of the aircraft, we can house it onto the aircraft. And our power consumption can be direct 120 volts or 220 volts. We can have solar off-grid options, and we're running at just below at full throttle. We're running right below 40 amps. We're about 38 amps at 120 volts. I want to jump into some of the use cases and some of the clients that are currently reaching out to us. Some of the use cases could be such as border patrol. search and rescue, emergency aid delivery, so drones as a first responder, rapid response, and also security. So these are some of the very interesting. And one thing that we do see is that the mining industry, oil and gas, are becoming the first adopters of our nesting station, specifically because their operational downtime is so expensive. And for them to have a downtime of a few hours could mean millions of dollars in loss. And they also have a lot of area to deal with. So we find that the oil and gas and also the mining industry to be one of the first adopters of the AERIEPORT. What I'm going to do is I'm just going to jump right now into a quick view of our AERIEPORT. We've made a small snippet commercial. So I'm just going to stop sharing and share that screen. It'll just be a quick second here.
Imagine a fully autonomous, remote, beyond visual line of sight drone nesting station that can be operated from anywhere in the world. Introducing the AERIEPORT. Fully weatherproof with an operating temperature between -55 and 55 degrees Celsius. A fully integrated HVAC system regulates internal temperatures. The onboard weather station provides you with a live weather forecast, including temperature, rain, wind, and humidity data. 24/7 availability thanks to its onboard 4SIM 5G high-speed connection allows you to operate AERIEPORT regardless of your operation center. Operations can be monitored and viewed using our custom software in high definition. Create missions easily using our custom user-friendly remote mission planner. Pre-flight assessments and risk mitigation can be accomplished using our integrated ground-based detect and avoid system, which can identify other aircrafts up to 2,400 meters away from the AERIEPORT. Intruding aircrafts are tracked to avoid a collision. With our scheduling assistance software, any active drone can be assigned on a mission and sent to run periodically. An illuminated landing pad and dual spotlights help ensure visibility anytime, day or night. During takeoff and landing, loud alarms are triggered so anyone in the surrounding area can stand clear and stay safe. Larger areas can be covered using multiple nesting stations. AERIEPORT gives the operator flexibility by allowing any drone to land in any nesting station. Once the aircraft has returned to a nesting station, the bars will engage, preparing the aircraft and batteries for its next flight. With the AERIEPORT, any mission can be completed from anywhere in the world at any time. At Volatus Aerospace, we believe that boundaries are meant to be pushed. Through its reliable connectivity, weather tracking, and an integrated visual detect and avoid system, the AERIEPORT will ensure an efficient and safe flight beyond visual line of sight. AERIEPORT, making beyond visual line of sight a reality.
Right.
Yep. Thank you very much, Pedram. I mean, the system really looks very rugged and for readily available for production deployment, as you mentioned, for various use cases. Again, the mining sites, the weather conditions, the dust and all those things would be extreme there, and that is where you would need these kind of rugged systems. So yes, that is really great, and the system being drone agnostic is another amazing factor, because every use case would require a different kind of drone, different kind of a payload, and the fact that system can adopt it is really great. So yes, thank you for that. We have some question and answers questions coming in from our viewers. We have a question from Apurva, that is, what is the charging time for M300 and what is deployment time for a mission?
So deployment time is under 3 minutes. So as soon as you press go, nesting station open up, charge bars open up. Within 3 minutes, you could be operational. Charge time, because we're using the DJI BS charging station, is identical to what the manufacturer has specified, which is roughly about a little under 45 minutes. But that's just because we're using DJI. If we do use other non-DJI systems, there are some that we can get anywhere between 20 to 25 minutes between flights for charging.
Right. Thank you. We have another question, and this is a question we are asking all of our speakers today. So, could you please share your thoughts on the open drone in a box approach, where each company contributes to a different layer of drone autonomy stack? And what are its benefits, and how can it help us grow the industry?
Yeah, definitely. A lot of different companies come from different verticals. They have different focuses. They also have different targets and aims. And that really, I really like that question because having an environment like that where everyone can contribute really helps because everyone has different insight. Some are more regulatory based, some are less regulatory, and more on the technology side. And we always know that there's a little bit of a clash between regulatory and the technology teams as well, as we like to move really fast and regulatory likes to take it nice and slow and make sure things are safe. So having everyone join together and bring a piece and kind of work towards a wholesome BV-loss solution, I think can benefit in many different ways. Everyone can bring something new to the table, and we can really open our eyes by learning from other organizations' experiences and others learning from our experiences in different verticals or different sectors. So I personally think it's a very great idea and has a lot of benefit for the market and pushing forward the BV loss reality. Yeah.
Yeah, that's a great answer, Pedram. Thank you for that. We have a question from Cody. What is the recommended distance between nests for maximum coverage of, say, long range inspections?
It really depends. So the current DAA system that you guys saw in that commercial, that gives us about a 5 kilometer bubble around our nesting station. So in reality, if you do have two nesting stations with overlapping bubbles, you can get just a little bit less than 10 kilometers between one nest to another nest, given that each have a DAA system. Using a radar DAA system, enhances that. So it gives you a little bit over 10 kilometers per nesting station. Really, our limitation here comes down to the DAA. That's only given in our current situation in US and Canada and parts of Europe because we do have that regulatory restriction. Some parts of the world, it's a little bit more free, let's call it, where you don't need a DAA, you can increase those and push those boundaries. But in areas that a DAA is required, the limitation really goes to the DAA side and really what limitations does the DAA in the market have. And another thing I want to add to that is right now we're working toward getting the DAA on board the aircraft. So having the DAA on board the aircraft, our safety bubble moves with our aircraft, and our aircraft can have an AI system or a system that can always make itself aware of its surroundings threats and how to divert those threats. So currently we're limited by about 5 to 10 kilometers, or sorry, 10 to 20 kilometers in range between nest to nest. However, in the future, we're going to see that increase drastically with new technologies that we're developing.
Thank you again for that. We have a question saying, what is the minimum internet bandwidth required for seamless operations?
Yeah, so if we're just talking about C2 link, just being able to get a heartbeat, we're looking at about 300 kilobytes. So we're not looking at much to be able to get C2 link pushing data back and forth. If you're looking as a whole package, AERIEPORT as a package, and you want to go full on, get your weather system, you want to get your C2 link, and you want to get the full data from your PMU and your HMS, your health management software, and your debugging software, you're looking at approximately 4 to 5 megabytes per second internet up and down speeds. But in most cases, if it's super remote where there's no LTE, SATCOM or perhaps even Starlink would be a really good acceptable option. And both SATCOM and Starlink can function on the AERIEPORT as we have designed it in a way to have lower bandwidth and still be able to operate.
Right. And what are the current use cases that you're seeing more traction from? The use cases want to apply more of these, adopt more of these technology?
Yeah, so the three that we found to be adopting the technology really fast is the mining industry. They seem to be adopting it. Again, I said it earlier. They're adopting it mostly because their downtime. It's going back on cost of operation. So downtime for mining companies could mean millions of dollars. So we're seeing the mining industry, also oil and gas, because both on the safety side of knowing if there's any issues in your property or in your operation, but also because they have such a vast area that they need to cover. And some of these areas could be very remote, which makes it really tough and treacherous for a human being to get there. So we're seeing those two being the leaders, and we're also seeing drone as a first responder be a leader. And we see a lot of use cases where they're trying to deliver AEDs or deliver any sort of medical supplies, easily administered medical supplies. So I believe those three are the three industries, and majority of this is either being moved and positioned forward because of cost of downtime or just inaccessibility of being able to go to that area. So that's really, those are the three that we see. We're obviously going to, in the next little bit, see more industries jump on board with the nesting station, but those three are the main ones that we see as early adopters.
Right. This question is coming from me. What would be a typical payback period for if, let's say, a mining site deploys this docking station? What does that look like?
That's a great question, because we actually had a scenario where we had to position to a client in terms of an ROI, so return on investment for a nesting station. We found that within 3 months, the nesting station would pay for itself back. And one thing that it does is the efficiency, the rapid deployment, and the data that you get at your fingertip is really the benefit there. But typically, we see about 3 to 3.5 months before return on investment, at least with the current clients that we're in talks with and we're running trials for.
Right, understood. And you mentioned mining being one of the common, mostly incoming use case. So in terms of mining, would it be inspection? Would it be surveillance? What more? I mean, there are more specific use cases when you go inside mining industry. So if you can shed a light on that, yeah.
Yeah, for sure. So what we've seen mostly is the security inspection side being more so prevalent in this vertical. So we do see that from the security side, making sure that, you know, if we do have anyone stealing things coming into your property or the area that the mine is. Also, unfortunately, some people do go into mines and they get stuck there, things like that. And one thing that we've done with our drone nesting station, we've made it open source so that you can have multiple trigger points. So what that means is that you can have a trigger from a security camera, you can have a trigger from a triggering system or like a laser trigger system, or it could be self-initiated. What that means is that you can have a feedback loop from your security system. If it does detect something, it could tell the nesting station, we've detected something at, you know, location X. Can you please go and give us eyes on? And that's one thing that we're seeing. Another one from the security from the inspection side is them being able to inspect multiple different parts of their property or their equipment at a really fast pace. So we do have a client currently that are located on a mountain, and they're basically crushing rock at the top of the mountain and moving it down. Every time they do that and crush the rocks and move it down, sometimes some of the rock chunks get stuck on their conveyor belt. And when that happens, they have to stop the operation and declog that area. And for that, they have to go and hunt for that entire few kilometers or 15 kilometers down the mountain. They have to search for where the issue is arising. So now they're using nesting stations to pinpoint it, and they're able to pinpoint it within 15 minutes, where before it was taking them upwards of 2 hours to pinpoint it. And we're looking at every hour they're losing about $3 to $4 million. So let's talk about cost of operation. 15 minutes they can detect it. Within 30 minutes they can unclog it. They're back up and running within 45 minutes. Where in the past that whole process could take a few hours to happen. So again, the cost is really the early adopters. Anyone that has a good savings, they're saving a lot of money, or making sure that their operations are running efficiently, those typically are becoming the first adopters of this technology.
Right. And as you mentioned, the ROI again is significantly increased and the payback time is reduced, considering one single drone in a box can address multiple use cases and multiple challenges in a particular site. So that's really great where the technology is taking us.
Yep.
Yeah. And if you can just give our audience an idea how the complete deployment process would work, how they can reach out to you, what will be the steps from POC demo to a full-fledged deployment?
Yeah, for sure. So one thing that we would recommend, obviously, get us involved, contact myself or anyone within our business development team, and we can share some of that info with you guys as well. And we would recommend to communicate with us. And what we would do is we would go through a proposal and make sure that we understand what you guys are trying to execute, and making sure that the technology does line up. Once we've done that, we would do a site assessment. We would deploy a nesting station on site, and we can start doing trials. After the trial is successful and you guys are happy with the data that you're acquiring, we would basically be there for ongoing support. Now, we do have two different options. Some clients would like to have their own internal flight operations team/software. Others say, no, you can deploy the nesting station on our property. I just care about the data. Just give me the data. And both of those are an option. So we can either deploy it, train your team, bring you guys up to speed in terms of how from the safety side, maintenance, operational aspect of it, and set you guys up as an organization. Or we can just deploy a nesting station, gather the data, and shoot the data out to you guys. Both of those are very possible. And we would give you guys full support from then on. You'd have a dedicated rep, both on the sales side and on the technical side, and we would be able to help you with ongoing efforts as well.
Great. Thank you very much, Pedram. Really informative session for our audience and for me as well, where how people they're learning how getting knowledge about how they can deploy the systems, what are the basic things that they need to understand, all those things. Thank you for that. And just wanted to ask you any closing thoughts you wanted to share?
The only thing I want to share with everyone is really what we've done here in the short amount of time and where this industry is headed. We know that BVLOS is the next big thing, and we know that it's coming. It's a matter of figuring out how we can coexist with current manned aviation, and also coexist with anything really that's in our airspace. And we know that cohesion is coming, and that's really where the AERIEPORT nesting station came about, is really regulatory. And I really want to recommend everyone to move through that approach, is make sure that they understand the regulatory side of things, and they understand the airspace laws, and we all move towards a pushing the boundaries with BVLOS. And that's really what's going to make this industry successful. By all means, I really encourage everyone to communicate with us here at Volatus Aerospace. Get in touch with us, not just for this, but really helping push the industry forward. We always welcome partnerships as well, and figuring out how we can work as a team together to get this industry more mature and really understand how we can execute everything within this industry.
Yeah. So thank you very much, Pedram. It was a pleasure talking to you, like always, and hosting you on NextGen. So yeah, again, thank you everyone for joining the session today. Hope everyone's having a great time at NextGen. And coming up in the next few minutes are more sessions. So please go to the sessions tab and attend the session of your choice. Thank you, Pedram, once again.
Thank you very much. I want to thank everyone for listening, and hopefully we'll talk to everyone soon.